Hello. So today we're just going to be looking at some demo waveforms with the NS1 oscilloscope here. So to do that we have a little makeshift waveform generator, which is actually being powered by a power supply back here, just because I ran out of 9-volt batteries. But anyway, that's not important. So let's take a look at the waveform generator schematic, just so you know what's going on. So we've basically got the 809833 chip, just a little breakout board for that, which is being controlled by an Arduino to command the specific waveform, and then we're running that through an op-amp, which adds a DC bias, just because I didn't want to add a negative rail and add some gain. So, and then we've got a little RC circuit over here. So let's start by taking a look at the actual waveform. Alright, here's the actual waveform. We do have to zoom in on it. You can see we're auto triggering right now, so it's flying across the screen. We'll just make a slight adjustment to our trigger level, and then we'll normal trigger it. So now we've got a stable waveform, stable sine wave. Let's measure the frequency of the sine wave. So we'll stop it real quick and use the cursors to do that. Should be about 10 kilohertz. And you can see, sure enough, it is. So that's cool. Let's get rid of those cursors and resume triggering. So we've also got a triangle wave and a square wave, which we actually have to adjust our vertical scale. And you can see the rise time on the square wave is actually pretty long, not really what you would expect out of a typical square wave, but that's likely because of that op-amp that it's going through. So, alright, let's, another thing we can do is take a look at the clock signal, which is used to control the 809833. Let's get on that, and we'll just try to do a waveform change, and you can see, sure enough, have the clock signal. Zooming is still a little buggy when the waveform is still, but or the waveform is frozen rather, but we're still capturing that clock signal. Alright, let's look at the that RC circuit, which is basically just charging that capacitor. Trigger, do a normal trigger, and we'll just see what we get there. We need to zoom out significantly to 1 millisecond about. Now let's see, yeah, so we can see we've got that. I'm going to move the trig level down. And let's adjust that scale, see if we can get it little blip there. Alright, cool. So we've got a nice clean charge waveform there. And we can see it's about 5 millisecond charge just from looking at the scale. And sure enough, if we go to the schematic, 10K resistor, 0.1 microfarad capacitor, that's going to be a 1 millisecond time constant, 5 time constants to charge, that's 5 milliseconds. So the scope agrees with that. So cool. So that's all I've got for now.